Today, we are developing our own number rounding functions, discovering another way to decipher strings, and we have a doozy of a time finding the maximum sum of a subarray of integers. Hello world, and this is the Versus Codewars. Uh-oh, somebody seems to have overwritten the math object's round, ceiling, and floor functions. Our goal here is to re-implement these functions. Let's go ahead and get started here. First, let's start with Math.ceil. This number is supposed to return the next integer from the number passed in. Let's go ahead and give this a try here. We're going to try to do this without using parseInt. So what we're going to go ahead and do here is const int string equals number dot toString What if I just tried toString with base 10 into string? Let's try feeding that into node here. Yeah, and that isn't going to do. So what we're going to go ahead and do here is split that with a dot and get the first element. We're going to go ahead and console.log that and see what that looks like. And we have an 88 here. What we need to do here, since we're going to go ahead and raise this to the ceiling, we're going to go ahead and hit return number int string plus 1. Feed that in the node here, and we should have our correct response of 89. We're going to do something similar with the floor method here. I just wonder maybe if we can do this without the number constructor here. Let's try just int string here. And no, that is not going to do. So yeah, we will need that number constructor. Maybe we will need parseInt after all. Feed that in a node and we still have our 89. Alright, well, we can do something similar with the floor function here. Just without the plus 1. And there we go. That just leaves us with the round function here. What we'll go ahead and do here, we'll do just as we did with the ceil and floor functions by splitting the string representation of the number with the dot and getting the first element. But we'll either floor it or ceiling it depending upon the result of the modulo operator. What we'll go ahead and do here is return number modulo 1. If that is less than 0.5, then we'll go ahead and just do parseInt string. Otherwise, we'll do parseInt string plus 1. This should give us 89, and indeed it does. Alright, with all of these functions now implemented, let's go ahead and try punching this into Codewars. And try to submit. And we have a problem. problem that can probably be remediated very simply by doing this. If number modulo 1 is equal to 0, then just return number. Alright, let's punch this new solution here into Codewars. And try to submit it. And we are good. Now, it's very easy to calculate the floor or the ceiling of a decimal number in JavaScript by simply using the parseInt function. To get the floor, just simply use the return of that function. To get the ceiling, take that return value and add 1 to it. As for rounding, there's 2 ways to go about that. Use the modulo operator on the number. Take that number divided by 1 and get the remainder. And if that remainder is less than 0.5, you calculate the floor of that number. Otherwise, if it's greater than or equal to 0.5, you calculate the ceiling. Another way to round a number is to just add 0.5 to the number passed in and then calculate the floor. Here are a pair of encoded strings. The strings are encoded as follows. The first character in the string has been replaced by its respective character code. Second of all, the second and last characters of the string, if they are not the same, are swapped. Our goal here is to decode this string and return what it's actually supposed to say. Let's go ahead and get started here. First, I think we should go ahead and decipher the character code. I think we can do this with a regular expression here. Console.log. Let's try to figure out this regular expression here. I think it's the start of the string. D plus. I think this is the character class that catches digits. Not match str. Let's feed this in a node to see what that looks like. Node to decipher this. Let's try and closing this in parentheses. That could be the problem. Nope. Okay, I have another idea. Const numeric matches equals dot match str. This is supposed to be a regular expression. Why is this not a function? Exec, maybe? Or match. Yeah, let's try console.logging that. Okay, first, actually, we need to split the string into its independent words. Const words equals str.split. And what we'll do here is return words.map word. Okay, what I think we'll do here is return no. Word equals word.replace. We'll use our regular expression here at the start of the string. use the digit character class. Let's go ahead and console log our match here. See if that works. Yup, it is. Our regular expression is catching the character codes. What we'll go ahead and do here is return in our replace predicate function from char code parse int match. We'll return our word so far, see what that looks like. And we do have our strings partially decoded here instead of the character code, so they are now showing their proper first letter. Alright, we're halfway there. Now we need to go ahead and swap the second and final letters of our string. What we'll go ahead and do here is go ahead and split the string into its individual characters. Const chars equals word.split chars at 1 equal. We're going to do a little bit of a swap here. Let temp equals chars at 1. Chars at 1 equals chars at chars.length minus 1. And then chars at chars.length minus 1 equals temp. And then we'll return the chars joined together with a blank string. Running that through Node, we should see our fully deciphered strings. We just need now to join them together with a space. Alright, let's go ahead and feed this into Codewars and see what this looks like. Trying to submit it. And we are good. Here we have another use of a regular expression, this time catching all instances of numbers at the start of the string. Here you noticed a new character class we used for our regular expressions. The caret makes sure we catch these instances only at the beginning of the string. Not shown in this kata is another character class, the $, which we could put at the end of a regular expression to only catch instances of that at the end of the string. By using both the caret and the $sign together, we can make sure that the string only consists of what we were looking for in our regular expression. Now, in hindsight, I could have saved the swap by checking the length of each of our words, and if it's only 1 or 2, just go ahead and return that word after we've done our replacing with the character at the character code. Alright, let's give this one a try. Given an array of integers, of which at least one is positive, this function calculates the maximum sum of a contiguous subsequence of any given number of integers in the array. Let's go ahead and give this a try here. First, we need to determine if the array is empty or consists only of negative numbers. We can do that by doing a temporary array here and running ARR through filter and filtering out any element of the array that is less than 0, or for that matter at 0. We'll try that later. Element is greater than or equal to 0. And if the length of our temporary array is 0, we'll just go ahead and return 0. Because that tells us our array is either empty or consists only of negative integers. Otherwise, if the length of our temp array is 1, that tells us there's only one positive integer in the array. We just go ahead and return temp at 0. Alright, with the sanity checks now out of the way, let's go ahead and get to the meat of this kata here. Alright, we'll go ahead and set keep track of the maximum sum of our sequence by doing this. Let maximum sum equals 0. And this is what we're going to go ahead and return. We also need to keep track of the length of each of our subsequences. Now I imagine a subsequence is going to be at least too long, so let sub length equals 2. Alright, we're going to run this through a do while loop. We're going to repeat this loop as long as sub length is less than or equal to the length of our array. And at the end of each iteration of our do while loop, we're going to increment our sub length, our subsequence length, that is. We're going to go ahead and do a little sanity check, feed this into node, just to make sure that do while loop exits. All right, what we're going to go ahead and do here is first a little if clause here. If sub length is in fact equal to arr.length, we can just go ahead and we're going to keep track of a current sum here. I think we'll do that up here. Current sum equals actually, I think we'll just go ahead and do a for loop here. Yeah, we're going to go ahead and do a little for loop here. For let I equals 0, I is less than arr dot length minus subsequence length plus I. First, what we're going to go ahead and do is make a slice of our array. Const sliced array equals arr.slice, or slice at I and until I plus subsequence length. Because I think that is exclusive. Yep, it is. So what we're going to go ahead and do is, first we're going to go ahead and console log that sliced array, see what that looks like. Feed that through node and see what that looks like. We have an error here. Yep. It's not subsequence length, it's sub length. Yeah, that's not gonna work. Maybe if I tried this. Or maybe this. Nope. Minus 3, 4, minus 1, 2. Oh, but it's not catching the last element of our array. What if we take the sublength and subtract 1 in our for loop? Alright, we should now have all of the possible subsequences in our array. Alright, with that being said, we should be able to do this. Current sum equals sliced array dot reduce, and we'll go ahead and get the sum of the elements of our sliced array. Ac val, ac plus val. We're gonna go ahead and console.log that and see what that looks like. And while we're at it, we can go ahead and do our check here. If current sum is greater than maximum sum, let's go ahead and set our maximum sum to our current sum. I think we'll move our console.log down here. We'll only log it if we have a new maximum sum. Feed that through node. And that should be right. Let's try feeding this into Codewars and see what this looks like. Try to submit it. Try to attempt it. And we've got a problem. Still taking the time to look through all the tests here and see which of these is failing. Expected 33, instead got 30. What we're going to go ahead and do here is log the sliced array as well. The sliced array that produced the new maximum sum. We're going to go ahead and reflect that in the Kata here. Try to submit it and get our logs. See, the issue with the tests in this Kata is that randomly generated arrays are included in these tests. You'll have some instances where all the random arrays pass, but you'll have instances as well where some of them fail. That's what I'm trying to get to the bottom of here. So I'm scrolling through these tests here, seeing What's going wrong here? Oh, wait a minute. Let's try setting our sublength to 1. I think I may have a eureka moment here. Just bear with me here. Copy. Paste. Run the test and try to submit. And we are good. Alright, this was quite the doozy that actually took more time than I was expecting, and actually more than one take to get just right. Where I was going wrong was, I was working under the assumption that the minimum length of a subsequence of integers for the sake of this kata was 2 elements. That was resulting in a few failed tests in some cases, and no failed tests in other cases, when it came time for Codewars to test our kata function against randomly generated integers. By setting the minimum length of a subsequence to 1, I was able to produce a consistent instance of no tests. And that is going to do it for today's episode of Versus Codewars. Nobody said it would be easy, but I'm enjoying every moment of it. If you like this video or you learned something new, drop a like and subscribe to this channel for more coding challenges from Codewars. As always, if there's anything I can do to improve on my code, feel free to make a suggestion in the comments section below. I hope you have a wonderful day, and I'll see you on the next episode of Versus Codewars.